soon as one application, if you're not reading your entire code base and just have any crawler go, individual who is hacking your computer, it actually starts from there. Because नहीं चाहिए. I know we are at the end of the event, and generally security भी actually सबसे last में ही आता है. It's very difficult to sell security to anyone in the world. Primary reason being, the first question that I generally get from our clients is that they ask us, what is your ROI on this? And how are we going to go and convince the upper management that we are going to pay you whatever X amount every month, but actually सामने हमें कुछ दिख नहीं रहा है उसका कि क्या हो रहा है. Like if you build a product in the form of anything, the end customer as well as your team sees something in front of them. Security is invisible, but it sits at the core of everything that can go wrong with your product, ultimately leading to your entire company going down. The idea of this talk is to keep you guys away from of whatever, if that's the case, if it can happen with you, to help you guys make sure that it doesn't happen with you, with whatever products that you are building. We are going to have a very simple checklist that you can basically have it in front of you before you start building your app, and that's exactly why we are having this session in lab 1, because security ideally should be done at the very beginning. Majority of the points that we are going to talk about here are going to give you an idea in terms of kaun-sa part of the security should be done at what stage of development. At the end of the session, Vivek will share a document with you, which is basically like a checklist. I'll take you through that document, what that document is going to help you with. That is what we are going to look at throughout this entire talk. And at the end of it, whenever you find time, please go through it, please put in your inputs in it as per whatever idea that you guys are going to work on, and take it forward and implement it when you are going to build your own application. So, like Vivek said, I am the CTO of a cybersecurity company, but before that, I don't like myself getting associated with just tech, because before I started doing this, I did not want to do it. I never imagined myself getting into tech. I wanted to be a cricketer, but unfortunately, due to any reasons, I couldn't do it. So I don't have a bat in my hand today, but now I have a mic. I have written, I write poetry is in Hindi, Marathi, English, but now majority of the time that I spent is in writing code, looking at the code of my clients. I also used to play tabla. I like music a lot, but now I don't orchestrate musical instruments, I orchestrate agents. I do a lot of programming with LLMs. Our entire team makes use of Gemini, Cloud Code, Codex, you name it, and we have it in the team for doing programming on the day-to-day basis. But there is a small reason why I am here today. Before standing here, I have built close to 20 plus applications in Flutter and React Native. So I know what is right and what can go wrong. I have been the Google certified associated Android developer. Basically, it was a certification program run by Google back in 2017. It was the first batch that came out. I was one of the developers who had got that certification. I have built a lot of applications that stretch in hardware and software both. So I have decent experience to come and talk in front of you guys about what we are going to do today. Not just in terms of security, but also doing things hands-on. So I can exactly tell you that, look, this is not just things that look good on paper, but exactly something that you guys can implement today. So I want you to take a note of the URL that you see here. It's a package called as Blutter, which is a name play with Flutter obviously. It's in short a reverse engineering tool to look at your Flutter applications. It looks at your Dart, your compiled binaries that ship along with your application. And there is a general tendency in app developers that whenever we have to push the application in Play Store or App Store, there is a process called as obfuscation of code that is done. Obfuscation in very simple terms means हमने अगर एक क्लास को नाम दिया है वॉट एवर लाइक क्लास का नाम अगर दिया है से यू आर बिल्डिंग एन एप्लीकेशन फॉर ई कॉमर्स दैट इज वन ऑफ द थिंग्स दैट यू गाइज आर गोइंग टू डू एंड यू हैव अ क्लास written in Kotlin or Swift which says say maybe like cart orders for example. Obfuscation, what it will do is basically name it something random, like it will ultimately in the code what lands is class ABC, that's all. It's making the code smaller at some times because obviously the larger your strings are going to be inside your application, all your other data types, the more play space is going to occupy. It obviously helps you bring your size down, but also one thing is important here is that if somebody tries to get your app into pieces and tries to look inside it, it will get difficult for them to understand what the app is doing. But it's very important to know here is that obfuscation alone cannot stop the application to get hacked from. It's just one of the measures as standard practices that are basically followed across the industry. But again, that's not going to help you not get hacked. Please make a note of this. It's going to be very crucial. Blutter essentially will give you a lot of output which can be gibberish for you guys. Make use of Cloud Code, Codex, others to take a look at that and ask them to see if there is any important information hidden inside it, like some keys that are being directly hard-coded inside your application or any application level credentials. Blutter can help you get access to all of that. Now, this, like I said in the beginning, security is more of a practice that you have to follow in multiple steps as you are building a product. It's not a feature. And sometimes you missing out on one of the major and important steps can cost you that entire product, and there is no coming back from that. So basically this is what we are going to look at. We are going to have a document with you guys which is essentially going to show you a scale, which I call it as an irreversibility budget. Your idea here is to take a look at every feature that's crucial in terms of security and see that whether it is cheap to implement whatever standard practices that are associated with that feature at this stage of your application, or is it okay to push it a little so that we can take it up in the other stages that are coming up, right? So let's start with one of the extremely crucial things where because of which one app in 200 on Google Play Store or App Store gets hacked very easily because they ship important credentials inside the app. This is the first thing which you cannot push it to other steps or tell your devs कि ठीक है बाद में देख लेते हैं, पहला app live जाना बहुत ज़्यादा important है. No, you can't do that. As soon as one application goes live on any of the stores, there are millions of other crawlers that are looking out for those applications to get mirrored and hosted on multiple different sites, right? APK Mirror and others, there are so many of them out there. And there is a high possibility that some or the other hackers already have written their own crawlers who are constantly looking out for these new apps, basically dismantling them, getting access to that code that is inside the app, the APK file, and trying to get access to all of these security credentials that you have shipped already. This is an extremely crucial thing that you have to do. Never ship anything inside a .env file. hard-coded inside your strings. Always make use of keychain and key store. Key store is basically, you can consider it like a locker room inside your phone, which is not accessible to everyone. Like as simple as your fingerprint sensor, right? The fingerprints, when you store or when you capture your fingerprints inside your phone, it is stored inside this space. Now on devices like Pixel, for example, they have a dedicated hardware chip on them. It's called Titan M2. There are different versions of it, which does this hardware attestation where your chips are stored literally on the hardware itself. And the retrieval process virtually is impossible to get hacked, right? So always make sure that if you have any credential, like maybe you're storing user's password, keep it encrypted. If you have any credentials that are associated, make sure it's under the key store. Never ever give your API keys out directly in plain simple text hard-coded inside your code. Next, client and server trust boundary. This is very important because a lot of the times when you build a product, it's not necessarily that it's going to be on a single platform. मतलब ऐसा नहीं होगा कि तुमने बस वेबसाइट ही बनाया है या सिर्फ मोबाइल ऐप ही बनाया है. It's very rare that this happens, right? And you're going to cater to multiple platforms. You're going to cater to a lot of different types of devices. It's very important to understand what logic should go on the client versus what is being done on the server. I have picked up a very simple example here. Whenever you go on Swiggy, Zomato, as soon as we put things in the cart, you see a final total there, right? With all the coupons applied and everything. If you have observed this, if you modify your cart in the same place, the section where the final cost is showed, that also reloads. Why? Because those calculations are actually happening on the server side. If it was client side, you wouldn't see those loading animations happening because all the recalculations are happening on the server and then coming back to the app. Why that is done? Because a lot of times applications are susceptible to attacks on the front end. And this is very dangerous. If you're doing your calculations on the front end and say, for example, there is a website where you're loading the cart at the end, and if all these calculations are done on the front end, it's very easy for malicious extensions or other parts of the code. If your device itself is compromised and there are some viruses or any sort of malware running on your system, they can easily go and modify things. And that could be very fatal to your business. Imagine finding flaws inside any of such apps where you are able to make the cart value as 0 and spending it out, right? That's going to be very dramatic and crucial for your business. Make sure that these kind of decisions are taken at the very beginning of your designing of your architecture. Again, super crucial thing, very dependent on what we spoke about the ENVs. What kind of data that you're storing in your database is also something that you have to take a look at. For example, username and password based authentication is a very common thing that we find in applications where a user inputs their password and a lot of times that password goes and sits inside your database, which is SQLite or whatever, inside the app in plain text. Now on devices that are rooted, basically you have bypassed everything and you can get access to the internal memory where all of these details are stored, which essentially gives access to the attacker to get inside and take a look at all of them. As a standard practice, whatever data that you are going to store in your database or anywhere else on the storage of the user's device, make sure that it is encrypted. There are some standard libraries that you can make use of. One of them, which is widely known, is SQL Cypher. There are packages available for Flutter as well. There are other packages like shared preferences. Have you guys heard about it? Android application developers. It's like a key value pair store that we generally make use of while building apps in Android. That also has a form of an encrypted shared preference, right? Again, whatever keys that are used for this encryption needs to be stored inside key store keychain. That again can't be in plain text, otherwise it just kills the entire purpose of us doing this encryption. Certificate pinning is a little nuanced topic where what you basically do is your backend application APIs this ensures that only your application can talk to your APIs. Any other request coming from the internet that is not directly coming from your application will be directly rejected. These kind of things are something that you can do at the later stages of your development. This is not something that you have to take care of at the very beginning. However, it's very important that all your communication with your backend happens over HTTPS at least. Nothing goes over HTTP. By default, these days, Android and iOS both reject you from making request over HTTP unless it's over localhost or your internal IP addresses. But when you will ship your apps to production, Play Store and App Store actually rejects them a lot of times. You have to be very explicit in terms of why you are doing calls over clear text traffic. You need to be very explicit what is your use case, only then they would allow it, otherwise the apps are straight away rejected. And it's very easy these days to have your entire pipeline from your app to backend over HTTPS using things like Let's Encrypt, which helps you mint certificates for free. Read about it. For a lot of you guys, it might be a new term to understand, but please go at home and read about it. By default, when you're designing your architecture for building your backend, make sure that every every API that you write, it's served over HTTPS. It's a very basic thing. The last, sorry. Why rotation? So what happens is generally these certificates, the SSL certificates, have an expiry associated with them. So if you are doing this SSL pinning, you have to ship that certificate, one part of it, along with your application itself. So when the application is communicating with your backend, it sends this certificate. The backend knows that, okay, I trust this certificate, I know this certificate, that's why it allows the request to move forward. But all the certificates come along with an expiry date. So you need to have a plan in place where you are able to rotate these certificates also. Otherwise, once it's expired, your application requests are going to be automatically rejected by the backend. The last and the most important part is the telemetry. The logging that you are doing for debugging purposes, or the logs with respect to user actions, any errors that are coming in the application that you're sending to your backend or any third-party services like Crashlytics, Posthawk, there are many of them. It's super crucial to understand what kind of data is going out. I have seen apps when we have audited our clients where there have been logs like after a user has successfully logged in, user has logged in with username, their username, password, their password. Now, this is horrible from a lot of perspectives. One, if you are into space such as healthcare, fintech, it's massive when it comes to PII and what use you are making of the personal information of a user. If such kind of things are found inside your logs hidden somewhere on your servers, you can lose your license as well as a company, as a product, which can ultimately cost you your entire company itself. A very simple small line added by some of your developer, very naive developer that has done this mistake. Make sure that this doesn't happen. It's great when you're doing debugging, you want to see, okay, the user has logged in, but they have forgotten to actually remove it when the app went into production. There are very simple ways to take care of this. You can have certain steps in your CI/CD pipelines when the application is built to remove all the console log statements, to remove all the logging statements inside. You don't need them. In production, nobody is going to take a look at it because every time there is going to be an error inside your application, there needs to be a separate error handling mechanism put inside. Like Crashlytics, Sentry, there are a lot of these applications that you can integrate inside your app directly, which will automatically send those logs as soon as they see any errors inside your application. You don't have to manually log your user's username and password. That's an extremely bad activity to perform. Again, something that needs to be done at the in the stages of your development itself and not at the end of it. There are certain standard practices that are put out by this organization called as OWASP, and they have this list called as OWASP Mobile Top 10, and these two have actually landed at the very top in the latest version that they released in 2024. First one says improper credential usage, which we just spoke about in terms of .env files getting hard-coded or hard-coded strings. Other is the data encryption at rest, storing everything in plain text in your database. Second is inadequate supply chain setup. Now, supply chain basically means, in terms of building mobile apps, your package managers from where you are going to download third-party applications, third-party libraries. Like in terms of Flutter, it's pub.dev, from where we generally download third-party libraries. Please make sure that you know what code is going to get executed behind the libraries. In the last 5 to 6 months or so, I gave a talk on this in Mumbai Tech Week as well, where a lot of these attacks have happened. Are you guys aware that GitHub also got compromised in May? It was exactly because of one of these kind of supply chain attacks that happened. So there was one VS Code extension, a very well-known one. It had like close to 10 million downloads. It was installed by one of the Microsoft's employees from the official Microsoft VS Code extension store, and that extension was compromised. So what happened was, after the installation happened, whatever malicious code that was running inside that extension, it got access to the credentials that were on the machine of the employee. And considering he was from the GitHub and the Microsoft team, obviously he had access to a lot of important stuff, and that is how the compromise happened. We generally don't look at a lot of things when we are downloading and installing these third-party libraries, but it can cause a lot of chaos and your product and business also at some point of time if it is terrible. Yeah, so that's the other thing that you have to take a look at and be very sure of. So this is what I was talking about. At the end of the talk, Vivek will share this document with you. It's going to have a similar scale. It's going to have the same questions that we looked at. You, in your context, the context of your application, you have to answer this and keep this document along with you. And make sure that after every feature that you are building, you are taking a look at all those questions and making sure that all of those are in check. This, especially, I have added this slide to talk about what issues and why securities has become all the more important, and what kind of issues have started creeping up recently because of programming with AI agents. Majority of the code that we write these days, hardly anybody is looking at them in very detail, right? We look at the UI, okay, fine, the button works, it does what it's intended to do, but actually what's happening in the code, nobody's taking a look at it. And that's a very big blank spot for you guys where things can go wrong. Hence, it's very important that these kind of things can happen, because the code that they are trained on, it's not the best code always. They have looked at all the open source repositories in their training data. They have access to the code that we as developers have written. And a lot of the repositories that are out there are written by developers who have just started their journey. Majority of them, imagine GitHub being so big and one of the largest right now where majority of the developers keep their code. It's bound to happen that majority of the code is shit out there. It's natural, right? Because we are learning. Even the greatest of the great developers will make some mistake at some point of time. Yeah, they have been trained on that kind of code, and obviously agents are going to produce that kind of code even in that 1%, chalo, like Opus and the greatest of the models that are out there right now. There is a high possibility that at least 1% of the code that they produce is going to have something like this. They might just have a local database with plain text credentials. They might have a .env or an API key hard-coded inside your application. Right? So it's very crucial that you take a look at all of this. Even if you're not reading your entire code base, please at least look at the kind of things that we have discussed today, so that we are very sure that at least this is not going into production. although I don't recommend not reading your code also. And like I said in the very beginning, this is extremely crucial. You cannot skip this step. As soon as you start writing your code and every feature where there are going to be credentials involved, you have to make sure that you cannot have secrets, API keys getting shipped directly inside your binary. And this is happening at a very large scale these days. We are having so many hackathons going around. You guys write your whatever ideas in like a span of 6 to 7 hours, heavily wipe coded, push to GitHub in public open source repositories with hard coded API keys inside it. It's a dream come true for anyone who doesn't have a credit card to go and purchase these API credits. They will just use yours. And it's very simple because it's all open, right? I can just have any crawler go out there and look out for these repos and just keep finding through it. I find millions of them. There are a lot of these advisories that are going out from a lot of companies to ensure that this is not happening. Irrespective of whether your repository is private or public, never commit your secrets. Say tomorrow there is a hack of one of your employees' computers getting hacked. The individual who is hacking your computer, they are going to get access to that private repository also, right? And if the credentials are there inside it, which technically means they have access to your database and AWS and everything else. So as a standard practice, keeping everything aside, this is a must done right from the beginning. All right, that's it from my side. In case you have any questions, feel free to ask. That's my LinkedIn. Please reach out to me if you're building something and need any help, guidance in terms of looking at your architecture, helping you figure out your security model. Please feel free to reach out. Thank you so much for listening to me. Any questions?
Earlier model was the static pinning of the certificate, but now there is a concept of dynamic. It's there in the already. So how do we implement that? The certificate or the public key or something is stored. What if that server is compromised?
That's a good question. And the server that you are basically going to hold. So here there are some problems that are basically assumed. You talking about your server getting compromised is basically your entire product getting compromised at some point. That server that you're communicating with, your app is communicating with, it's basically your backend, right? That we are talking about. So your backend getting compromised in itself is a very big issue because your backend is going to have your environment credentials that your applications are talking to, like your database credential would be there, your API keys would be there, your secrets would be there. So it's a different, I would say, like an attack vector that we are talking about, nothing to do with the SSL pinning. Because even though that what you're talking about is the public key of the certificate inside your app, but the private key is on the server, your server in itself has been compromised. There is honestly nothing that you can do about it. And your actual exchange of the certificates are happening on that same server itself. So if the server itself is compromised, then basically there is nothing that you can do. However, it doesn't necessarily mean that the application also is compromised, because your application only talks over the API key unless and until your API's code itself is now compromised and has started sending responses which are malicious and storing it on the device and then doing something. That's a different case. That can be one of the attack vectors over there, but you cannot stop that from happening, because once your server is compromised, then basically you're done. Sure. Any other question?
Yes. If I have to avoid rotation, then what would be the alternative?
You can have long-lived certificates. Basically, the expiries can be. I mean, see, the SSL pinning is a layer on top of what you're already building, right? Because you cannot have whitelisting of domains in this case, because apps don't have a domain with them. Long-lived certificates are okay. It's not recommended, but it's not a big deal. It's not something that you would say, oh, you should not do it at all. It's fine, you can do it, but it's not recommended for reasons like somebody can try to get that certificate out and make use of it somewhere else. That's primary one of the reasons why they don't recommend to have long-lived certificates. But it's all right till the time the authentication layer of your APIs below it is all good and your server is able to handle, like what can happen worst case scenario is this certificate getting used across multiple different servers, right? Like a DOS attack that's trying to achieve. If your servers are able to handle that, it is okay, but it's not recommended again to have long lived.
Wonderful session.
Thanks.
Say this precautions are basically if you are developing yourself. As an enterprise, many times you outsource the work.
Yes.
And basically the code is not in your access.
Yes.
How do you ensure that the product or code which is developed for you are securely safe?
Understood.
Couple of things can be definitely verified, but everything is not can be verified. So how do we care about?
It's a very good question actually. So generally what we recommend clients, because this happens with us also, like a lot of clients come to us for looking at security for the applications that they have not built. So this is one of the approaches that you can take. But before coming to a security team, one thing that you can do is have an external consultant or some, obviously if you have outsourced it, there can be two reasons. Either you don't have a tech team in-house or you are tied up. Basically your tech team is tied up and not able to take up the work. So if one of your team members who is technically sound, a little senior, can take a at least look at the things that I mentioned here, independently by him doing a proper audit, that is one approach that you can take, because that is cheap. You don't have to get someone on board and give them money separately, right? But if that's not possible, then it's obviously advisable to have an external security audit done of the product before it goes live. Especially becomes all the more important when you are doing it from an external third party vendor, because generally what you have observed is that they build these applications on some blueprints that they already have, like boilerplate codes that have already been used across other applications. Like e-commerce is a general thing, right? So they can have templates written around e-commerce and they just make reuse of it. A lot of times these applications are not updated. The libraries that are used inside can have a lot of security vulnerabilities inside them and they are not updated, they are not up to the mark. So you need to look at all of these things as well. Like how old is the source code, what libraries they are making use of, are those libraries updated, is the source code updated to the latest versions of those libraries. All of those things need to be done, which generally is a good practice to be done by a dedicated security team, like a proper audit of the code base. And they have to give it, because ultimately it's your app, right? So at least this holds, and it also depends upon what kind of contracts that you have done with them. So it actually starts from there, because if you have just had a contract with them saying they'll just hand over the app to you, then it can get a little tricky, because then they might not give you access to the source code. Any other questions?
Avoid supply chain attacks. So suppose if I am using any of the packages, so what thing I should check before just
So first thing that you can do is do an online research. If there are any basically news or any issues open on their GitHub which talks about applications getting compromised, because the library can also depend upon other third party libraries, right? So that's something that you can do. One. Second is how frequently the package is updated, how frequently the developer is taking a look at it, because then if the package is updated constantly, then automatically the underlying packages are also kept up to date. That is again second thing that you can do. The third and the recommended way that we generally tell people is have your own internal package manager system built over GitHub or something like that, where you directly don't update your packages from these GitHub sources or npm or pub.dev directly, but instead do it from your internal GitHub repository